Welcome to a new lesson. Applying the trigonometric ratios. Let's take a look at an example. Solve triangle XYZ. Give the measures to the nearest tenth. Solving a triangle means that we have to answer and find all the lengths and all the angles of a triangle. The first thing that I'm going to solve in this triangle is the missing side. We can use Pythagoras for this purpose. Recall that the hypotenuse always faces, the 9 degrees always faces the hypotenuse. That is the longest side of the triangle. Therefore, we could solve this side by c squared is equal to a squared plus b squared formula, the Pythagoras formula, where c really is h. So let's solve for c. We know that a is 6, b is 10, and when we solve for c, we'll take the square root of 6 squared plus 10 squared, and therefore c is equal to 11.7 centimeters. And your common sense tells you that it is the longest side, and it is longer than 6 and longer than 10. So it's probably the right answer. The next part is to solve for one of the missing sides. One of the missing angles. It's up to you what angle to choose, either x or z. I am going to solve for the x. Since I'm solving for the x, with respect to x, the 10 is the opposite side, while 6 is the adjacent side. And while c, which is now 11.7, is the hypotenuse. It is often good practice to use the numbers that were given in the question originally, and not to use the answer we obtained through the course of the question, because 11.7 could be wrong. There could be an error in it. It could be rounding off problems. So that's why I'm going to use 6 and 10 to solve for this question. I'm going to use opposite and adjacent. Do not forget to write SOHCAHTOA, because this will let you know which trigonometric ratio you're going to use. And since we're using opposite and adjacent, we're going to use tan. So tan of this angle x is equal to opposite of adjacent. So tan of this angle x is 10 over 6. Then when you're solving for the angle, we always have to find the inverse, in this case of tan of 10 over 6. And since we're answering to nearest tenth, the angle is 59.0 degrees. So this is our x value, x angle. The last thing we need to solve for is this unknown angle z. One rule in a triangle describes that the sum of all angles in a triangle is 180 degrees. So we're going to use this information to help us solve for z. This means if we take 180, subtract 90 because of this 90-degree angle in it, then subtract the 59-degree angle that we obtained the x value, the angle x, and the resultant will be our angle z of 31.0 degrees. And this is our angle z. Let's take a look at a different question. Given the following triangle, solve it. Give the measures to the nearest tenth where necessary. Again, solving the entire triangle means that we have to solve all the sides that are missing, as well as all the angles. We could do the angle right away, knowing that the sum of all angles is 180. We subtract it from the 90 degrees, which is the little square that we have here. Also, we have to subtract 25 from it. So our missing angle turns out to be 65 degrees. This is angle D. This little symbol right here means an angle. The next part is to solve the missing sides. So let's label the triangle with respect to the angle that we know, 25. We know that this is the opposite side. We know the 90-degree angle looks always at the hypotenuse, which we do not know, and the missing side is the adjacent side as well. So again, write SOHCAHTOA to refresh your memory about the trigonometric trig ratios. And then we have to decide. I want to solve for hypotenuse, and I have opposite. Well, that is sine ratio that we're going to use. Sine of the angle of 25 is opposite of our hypotenuse. So sine 25 is 5 over the hypotenuse that we are looking for. When we cross multiply, we are going to interchange the sine 25 with the h. So we get h, and 5 divided by sine 25. As long as you are in degree mode and divide, you should get the hypotenuse of 11.8 centimeters. So that's one side. Now for solving the adjacent side, we could use Pythagoras, or we could use another trig ratio. In this case, I'm going to use a trig ratio instead of Pythagoras. So again, we have opposite, but we're looking for adjacent. So this time we're going to use the tan ratio. So we have tan of our angle, which is 25. Notice I'm using 25 instead of 65. It is good practice to use the angle that we are given in the question instead of the angle that we solved for. So again, it's opposite of adjacent, and just plug in those values. So for opposite, which is 5, and this is adjacent. We're going to use the same method as previously to interchange the adjacent, the unknown, with tan 25. So we get adjacent is 5 over tan 25. And as long as you're in degree mode, maybe you have brackets, we get the adjacent side to equivalent to 10.7. And don't forget centimeters, like so. Also, you should be always thinking about the question when you're doing it to see if your answers make sense. The hypotenuse should be the longest side. It is 11.7. It is larger than 10.7 and larger than 5. So it does make sense that your answers do make at least common sense. So use your common sense to make sure that your answers do make sense to you. So we solved example 2, but there's an important thing about this triangle you need to know. So I'm going to erase everything, and we're going to talk about a little bit of naming of the sides of this triangle. So let's take a look at this triangle. There is an interesting way, not really an interesting way, but there's a different way of naming sides. This side is called DE. It's called line segment DE, but also because the F angle is looking at this side, is opposing this side can also be called small f. Same thing for the opposing side to the E. Notice the angle is a large capital E, uppercase, and the opposite side is lowercase e for the side, even though it can also be referred to as line segment DF. So what is left? The angle D is looking at lowercase d side, even though this line segment can also be called FE. So make sure that you understand that the angle has an influence upon which side is looking at, and that side has the same name but just lowercase of that angle that it's looking at. Let's take a look at the last example. A small table has a shape of regular octagon. That means 8-sided figure. The distance from one vertex to the opposite vertex measures through the center of the table is approximately 30 centimeters. There's a strip of wood veneer around the edge of the table. What is the length of this veneer to the nearest centimeter? So what the question is asking is that if I would take the perimeter of this table and measure it, what would it be? Except we can't measure it. The only information that we know is that across from one vertex to another of the table for the center is 30 centimeters. Sometimes in the questions you will have to make some triangles. There are no triangles given in this question, so let's make some. Let's make a triangle. Let's connect the center of the table to all the vertices or the corners. When we do this, we realize that there's 1, 2, 3, 4, 5, 6, 7, could be 8, probably is. It is 8. There are 8 triangles, and they're all the same triangles. We also know that all the way around in degrees in a circle is 360 degrees. So this means that if we divide 360 degrees by 8, because there are 8 triangles, we could find the measure of each corner, or the inside corner edge, of the triangle. And this answer is 45. So in the picture, it means that each of these angles is 45 degrees. And so on, and so on. All these angles are 45 degrees. Yet we still don't have a right angle triangle. Remember, the SOHCAHTOA only works on right angle triangles. Yet we don't have one. So we have to draw another triangle. Where would we do it? What we would do is we would take one of the triangles and bisect it. That means equally divide it into 2 parts. So we're going to focus on that triangle right now and see where does this take us. Okay, so I enlarged it. Let's take a look. So this is 45 degrees. If we bisect it, we get a 9 degrees, and we get half of 45, which is 45 divided by 2, we get 22.5 degrees. So 22.5 degrees for this angle. What we are really interested in is knowing this base of this triangle. If we find one of these bases, we just multiply by 8 because it's an octagon, and then that's the perimeter we're looking for. What else do we know about the question? We know the angle. Okay, great. We know the angle. But that 30 has something to do with one of these sides. Well, it's not the height of the triangle. It actually has something to do with this part right here. We know that from one end of the vertex to all the way to the other side of the table, it's 30 centimeters. And this orange part, or side of the triangle, is half of 30, which in this case is 15. So we have an angle of 22.5 degrees, and I'm just going to erase the 45 because that's a little bit confusing. We have an angle, we have the side, we can find now with respect to the angle of the opposite side. We have that, it's not 15 degrees, 15 centimeters, little mistake there. We know that the 15 centimeters is the hypotenuse of this triangle because 90 degrees is looking at it. We know what SOHCAHTOA stands for. We have the opposite, so we're looking for the opposite. We have the hypotenuse, we are going to be using sine. So let's use sine. Sine of any angle is opposite of hypotenuse. Sine of our angle, which is 22.5, is opposite, that's what we're looking for, divided by the hypotenuse, which is 15. So we're looking for the answer that's less than 15. The next part is that we cross multiply by bringing the 15 from the denominator to the numerator. So we'll get 15 sine 22.5 is equivalent to the opposite. Therefore, the opposite side is equal to 5.74 centimeters is the answer for the opposite side. We're not done yet. We're almost done though. So we basically said, okay, this is 5.74. This red part. How many of these red parts go all the way around the octagon? Well, in this triangle, there are 2. So we're going to multiply this by 2. And since there are 8 other triangles like it, and they all had 1, 2, 3, 4, 5, 6, and a total of 8, we're going to multiply this again by 8. And we'll get a brand new, so the perimeter of it, or the length, will equal 5.74 times 2 times 8. And to the nearest centimeter, it's 92 centimeters. And this really is your final answer, and not the 5.74.